Hi, welcome to Algebra 2, Lesson 3-6, Quadratic Formula, Example 3. Identify the number of real number solutions. How can you determine the number and type of roots for a quadratic equation? So in this example, we will see the types of solutions we can have for quadratic equations. So first of all, we're going to have three different examples. We're going to graph each equation and use the quadratic formula to find the roots. So if you graph the first equation, we have a vertex at 1.75 comma negative 3.125, and we have two zeros, which means we have two roots and two solutions, two real solutions. The second equation, we have the vertex at exactly negative 1.5 comma 0. So this itself is a root and a 0 and a solution. And we only have one exact solution. Okay, and then the third one, we have the vertex at negative 1 comma 7, which this graph doesn't even go through the x-axis. So there's no solution, but it just means we have no real solution. So no real roots, no real zeros. But we may have imaginary or complex numbers as solutions and zeros. So let's use the quadratic formula and solve for each solution. If you use the quadratic formula, for the first example, you'll get two real solutions. For the second example, you get one exact solution. And the third example, you have two imaginary numbers, right? Two complex solutions. So what is the difference? Can we just look at the vertex and say, but what if we just have equations? Do we have to graph every time? No. If you look at the quadratic equation, you can already tell if they're going to have real solutions or not by just looking at the signs inside the square roots, right? You know you cannot have real solutions when the radicand is less than 0 or negative in your square root, which is not possible in real life. So that means when your radicand is negative, then you have complex solutions. When the radicand is positive, you have two real solutions, and when it's exactly 0, square root 0 will not change, will not have two solutions, because if you add 0 or the minus subtract 0, it's still going to be the same answer, right? So in this case, your solution will be just 1. So this radicand inside the square root is called the discriminant. This is very important, right? So we gave a name because it determines how many solutions we're going to have for quadratic formula. So this is called the discriminant, and the discriminant could be represented as b squared minus 4ac when you have a standard form of the quadratic equation. So when the discriminant is greater than 0, which means it's positive, you have two real roots. When the discriminant is exactly 0, you have one real root. Okay, and then when the discriminant is less than 0, which means it's negative, you have two non-real roots. You will never have one non-real roots, because if it's just one solution, it's just real solution, because if it's 0, then that's the only way you will not have a plus or minus that are different, right? Yes, so let's try number 3, A and B. So part A, 16x squared plus 8x plus 1 is equal to 0. B, 2x squared minus 5x plus 6 is equal to 0. So please pause the video and see if you can figure out how many solutions each equation would have using example 3. And come back when you're ready for answers. Okay. Are we ready? So you don't have to solve for the solutions. You don't have to solve for the actual solutions. You have to describe the nature of the solutions for each equation. So that means how many solutions would there be? Is it real numbers or non-real numbers? So you can say either, you know, one or two real solutions, one or two two non-real solutions, and show work. Right? So how do you know? Because we learned that discriminant will determine how many solutions there would be for the quadratics. We can look at the discriminant to figure out how many solutions there would be, right? And first of all, your first step is to identify your A, B, and C. A is 16 here, B is 8, and C is 1, right? And your discriminant would be able to, you'll be able to figure out using A, B, C, right? B squared minus 4AC is the discriminant. So for part A, you have to plug in 8 squared minus 4AC, and that's 64 minus 64, and that's equal to 0. So 0 is a real number, but you're only going to have one real solution. So the answer would be 1 real solution. And that's it. You just have to write how many solution and what type of solution you have for this problem. Part B, do the same thing. A is 2, B is 5, C is 6. So B squared minus 4AC would be 5 squared minus 4AC. So that's 25 minus 40, so that's 24, 48, right? And so you're going to have a negative solution, 23, negative 23. And so this means your square root, negative 23, will make two non-real solutions because it's plus or minus square root negative 23 in your quadratic formula, right? So if your discriminant is negative, it means you have negative inside the square root. That will give you imaginary number, and that means you will have complex numbers as solutions, which will be described as two non-real solutions. Okay, so we looked at the discriminant of the quadratics, and the discriminant doesn't help you figure out what the x actually is, but it helps you expect how many solutions you'll have and what kind of solution you would have. So when we're talking about discriminant, we're just talking about how many solutions and what type. Is it real or non-real? And the discriminant, again, is the b squared minus 4ac in your quadratic formula. Is the radicand inside your square root, under your square root. And remember, your quadratic formula works for any quadratic equation. So using your quadratic formula, if the discriminant is positive, you would have two real solutions. If it's 0, it's just one solution. If it's negative, you'll have no real solution, but two non-real solutions. Okay, so that was example 3. In the next video, we'll continue with example 4.